All right, let's go ahead and learn how to move a character using C++. So if you don't already, you're going to need to install the project Jenova. You can catch that in the previous video. Hopefully I'll remember to link that up in the corner. And today we're going to go ahead and make the sprite move. Now, we learned a lot last weekend. And today we're going to go ahead and make our player move. So I just have a 2D scene here called made. I have a static body with a collision shape 2D. That collision is this world boundary here. Then I just have a character body 2D for my player. It's got a sprite and a collision shape. That's it. Nothing fancy going on here. Alright, so we're going to go ahead and add a script onto our player. We can just leave it named player, that's fine. A C++ script, inherits from character body 2D, yep, that's all fine. And we'll hit create. Alright, so we have our script open up. I don't like all the white here, I want to have my color, so now that the script exists, I'm just going to close it and reopen it. There we go. Now, if you remember from last time, we're actually going to need to include our character body 2D class here. And we need to, we're going to provide input to our character. So we're going to also need to include the input class here. All right, so we're going to include Godot /classes /input.hpp and Godot /classes /character _ body 2d.hpp. All right, so we have that. And if we go to after it says Jenova script begin, we can start putting in our variables, and the one that we want to put in is going to be the Jenova property. It's going to be an int, it's going to be speed, and I'm setting it to 100 here, but it can really be any number. This is just our default value, and I'm going to go up to the top right corner and I'm going to hit build. And I'll just give that a second. You can see no errors. Good. That means we have things in the right spot. Don't forget your semicolons on the end, because this is C++. And if I go to my player and take a look at the inspector, I can see my speed. This is where we can go ahead and tweak it. I'm going to set it to 500 just because I know that number is going to work well for our demonstration here. Okay, so we're going to come on down. We take a look. On awake, well, that's on tree entered. We don't need that. If you wanted, you could delete it. On destroy, so this is on tree exited. We don't need that either. On ready. For this, no, we're not going to need that. On process, close, because we're moving around a physics body though. We're going to do void on physics process. And don't forget our arguments, the exact same thing that process has here. So this is going to be our caller instance and our variant, that's a delta. And I'll delete the process. All right, so all we have here is our includes at the top that we added. We have the variable we created, or the property, and we have our physics process that needs its curly braces. There we go, got to remember those. And save. If we go ahead and run a build, we should have no errors, showing that we're on the right track. And if you couldn't see that change, I'll clear that, hit build again. We can see no errors, we're good. So far so good. Now we need to go ahead and get ourselves a self, right? And that's going to be from the instance here. So I'm going to create a variable here called self, and it's going to be cast as a character body, that's with a capital B, 2D. Put the asterisk there. I'm going to call it self because that's what I'm used to. You could call it this node if you wanted to, or just this, depending on your preference. But self is what I'm comfortable with, so that's what I'm going to use. And this can be equal to get self, capital G, capital S. We're going to have our carets, our greater than, less than. Inside here, we're going to put in the type, which again is character body 2D. And outside of that, we have our open and close parentheses where we can just pass in instance and end it with your semicolon. Save that. Run the build, make sure we haven't no issues. All right, it looks like we're still good. That's great. All right, so next we're going to be using input. So let's go ahead and get that singleton. That way we can use it easier, just like in GDScript, where we would go like input dot is action press, for example. We want to get this singleton and assign that. So we're going to do an input star or asterisk. I'm going to call it input with a lowercase I, and we'll assign that to input with a capital I, colon, and what this is we got our class here, and we're calling a function on it, right? With C++, double colons here it's a common thing, and what we're going to be calling is get singleton. That's get, all lowercase, underscore singleton, open and close parentheses, semicolon on the end. Save it, and if you've written it right, again, you can run a build after that line. Everything should be fine. Awesome. Our code is fine. We're getting the input correctly. And this is why we needed to include the input class up top. Because if we didn't have that, this is where we would run into our first error, because we wouldn't know where this is coming from. All right. So to keep track of some of this stuff, we're going to go ahead and create our own velocity variable here to keep track. We're just going to call it vel, V-E-L. And since we're working in 2D, this is going to be a vector2 vel. So we're going to set our vel to, we're going to use curly braces here, and we're actually not going to use equal. So vel, curly braces, and inside of here, we'll do self, point that arrow to get underscore velocity, open close parentheses, all lowercase, and outside of that curly brace, put a semicolon. Now, and as you know, in Godot, we do have to use a move and slide, and we need to set our velocity. Right, so let's go ahead and do that, and then we'll worry about the in-between stuff that works with that. So we're going to do self, point that arrow, move, and slide, all lowercase, with your underscores in between, just like with GDScript. Open close parentheses, semicolon. And before we call move and slide on the immediately previous line, we'll go ahead and we use self to call set velocity, and we'll pass in our vel as the argument, end it with a semicolon, run a build, make sure we have no errors. Looks like we're clean. And if we run it, see, no issues, and we have no errors in our build. Perfect. Nothing happens, but we have our information, right? We have our variable self being assigned to our character body 2D here. We have the input singleton, so we start asking for input. And we have our vel, or velocity, that we can modify and pass in order to change the velocity of this character body, this physics body. All right, so the question is, or at least our next question is, how do we get input? Well, we're going to be doing this with, we're going to be using an if statement here. And just like with C#, we have our open and close parentheses here. And then we have our curly braces that follow it. Now, if you want to have them like this, to where they start up here, that's fine. If you want to start on a new line, that's up to you as well. That's personal preference. And inside of these parentheses is going to be our condition. Now, our condition is we want to see if the user is pressing up, for example. So just like you would, if you think about it with GDScript in mind, right? We're getting the input and we're going to call the function isActionPressed. So with C++ here, we're going to use this arrow from input and do is_action_pressed, open close parentheses, and this will take a string argument. This string is going to be, since I'm just going to use the arrow keys here, UI_up. Right? So if we were to come down here and do output and pass in a string, we'll say up has been, or is being pressed, and remember to end that line with a semicolon, save it, do a build. And if we go ahead and run that, if I hit the up arrow key, we can see up is being pressed and it's getting printed straight out for us. So we see this is how we are going to get our input. And this is going to go up. Whoops. So otherwise we would have an else if. Right? So we actually have to write out the entire word else if, no elif. Our open and close parentheses for our condition and our curly braces. So I'm just going to do the same thing here. So we'll say down is being pressed, and we'll do our input arrow is_action_pressed, open and close parentheses, and the argument here will be UI_down for me, because we're using the arrow keys. Build, no errors, run the project and test it. Up is being pressed, and if we hold down is being pressed. And you see we can alternate between them. Awesome. So what we need to do now is actually change our velocity. So if we're going up and down, this is going to be on the y-axis. So instead of output, we're going to do val.y equals. Now, if we're going up, that is going to be positive, I think. I always seem to mix this up. But we're going to put in our speed. Make sure to end that with your semicolon. And if we press down, it's going to be our negative speed. Save, build. Hopefully I didn't get that backwards. And we'll test. If I press up, I did get it backwards. We went that way. And if I hit down, we're actually moving up, and away we go. So I got those backwards. Let me just fix those. So negative is up, down is positive. And if we take a look, give that a try again. Down, up. And you can see it just keeps going up forever. And if I hit down, it's going to keep going down forever. And the only reason it stops here is because of that world boundary. Right, so up, it's going to keep going forever. Down, it'll go forever. And that's because we're setting the velocity, but it is never being set back to zero. So we'll put in our else. And else, of course, doesn't have a condition, so we just use curly braces. I'll say val.y equals 0. And our semicolon. Run a quick build. Check for errors. Run our test. Up, we're good. Down, we're good. So now we can stop when we let go of our button. All right, so we can do the exact same thing with our left and right. So if you want to type it out, that would probably be best practice here. I'm going to go ahead and just paste it on down. Another if, else branch. And I'll do UI left, UI right, and I'll change these from velocity.x to velocity.y. Or sorry, from y to x. And if we run that build, that should be perfectly fine because I just copied it over. If you have errors, double check your lines. And if we test it, we can now go up, down, left, right. And we can move as much as we want. As soon as we let go of any of the buttons, we stop moving vertically. Or if we go up and down, we stop moving horizontally. If we let go, we just stop moving, period. Fantastic. So we can see at this point that we have a lot of these movements going for us. Now, what if we wanted to use gravity and get that involved here? Well, we're going to have our condition at the top, right? Because we need to know whether or not we're on the floor. So if, open and close parentheses, and curly braces here. And our condition this time is going to be self, arrow, point, is on floor, open and close parentheses. And we want to check if not. So we want the negative. So if exclamation point self, arrow point is on floor, then do this. And what is this? Well, it's going to be vel plus equals self point get gravity, all lowercase, open and close parentheses, end it with a semicolon. Run your build. Hopefully we have no errors. Test it and we should see ourselves drop. Oh, but we're not. Now that's curious. Why is that? That's because if we're not on the floor, we're applying gravity, but then immediately after, we're looking here, we're like, oh, well, we're not pressing up or down, so we're setting it to 0, so we can't fall. And same with the X. So what we would need to do now is take this and put that inside of an if self is on floor, so we don't want the negative connotation, and then just paste it all inside of there. So basically we're going to say if we're not on the floor, get gravity. If we are on the floor, then we're going to look at our inputs. If we run that and test, we fall immediately to that world boundary and we can move around. Now up and down is going to be a little difficult with gravity pulling us. As you can see, we're just kind of bouncing when we're holding up, and of course down does nothing for us. But left and right still works perfectly fine in this example. Alright, so you're getting input. Showed you how to set your velocity and you can move around. Showed you how you can apply or get gravity and do your on-floor check. Now, all of this is very, well, a little crazy, right? To have all of these if, else, else if, else if, else if, else, all of this stuff. It's a little insane. So what we can do is we can use another option from input. If you remember my video, or if you've seen it, the one where I went over all these different options or different ways to get input from the player, we're going to get the input vector. All right, so we're simply going to say self, if we're not on the floor, we're still going to apply that gravity. If we are on the floor, all we're going to do is we need to get our input direction. So this is going to be a vector 2. You can just call this dir if you want. For the direction equals input, point that arrow, get vector, open and close parentheses, end that with your semicolon, and you're going to pass in your arguments, which of course can be your strings of starting with your horizontal, negative and positive, and then your vertical, negative and positive. Right, so that's going to be left, right, up, down. All right, so now that we have this direction that we want to move in, all we have to do is apply this. So we'll say vel x equals our dir dot, and we're going to normalize it here, dot x. Now you could use an entire separate line to just normalize the input completely, but I'm going to save myself a line and just do dir dot normalize dot x times our speed. Whoops, and that's going to be vel dot x, and we're going to do the same thing here. Vel dot y equals dir dot normalize dot y times speed, and that should, both of those lines should end with a semicolon. Save that, run a build, hopefully no errors. Perfect. And really, you don't even need the Y in this case, but you'll see we're gonna have the same output here. So we still have our left and right, our down does nothing, and our up gives us the bouncies. Boing, 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 boing. So in this case, we don't really need the Y, but if we just come up, and if I were to just comment out the gravity portion, so we can take a look, run another build since we changed the script, and take a look. Oh, it seems we ran into an error. What did we do? We did not run into an error. Oh, because we're not on the floor anymore. That's right. All right, so I'll just pull that out. Go. So if we remove gravity or ignore gravity, right, then all we need is get our self, get input, create our initialize our velocity, get our input vector, set our x and y of vel, then call set velocity, pass in vel, and move and slide. Go. There we go. I guess I just wasn't holding my function button because I don't actually have physical arrow keys on my keyboard. But there we go. There's our movement. All right. So I've shown you how to do things like getting vector, if that's your preferred movement style. How to get the input singleton, so you can start getting input. How to use the if-else with C++. How to detect if you're on the floor, and how to get gravity and apply it to your vel. Alright, so just like the last video, there's quite a lot going on here. Hopefully you learned quite a bit to help you get going and start moving around your own player characters if you want to start making your games in C++. Alright, that'll do it for this one. Take care, have yourselves a good one, and I'll see you guys next week.